In this module, we will see about the decimal expansions of real numbers. Correct? But before that, do you remember what was the set of real numbers? We had said real numbers is a combined set of rationals as well as irrational numbers. What we'll quickly see today is that what are the decimal expansions of rational numbers and what are the decimal expansions of irrational numbers. Right now on your screen you can see we have taken two examples wherein we have divided 117 by 4. The long division is already shown to you. You can see that the expansion terminates. There is a remainder 0 and finally the answer we have got is 29.25 as the quotient and the remainder was 0. Whenever the remainder is 0, we say that the decimal expansion has terminated. We have one more example, that is 13 divided by 15. If you divide 13 by 15, you can do it on your own. You will get 0.86666 and that 6 goes on recurring. Ultimately, how we do we write it as 0.86 and a small dot over 6, which means that 0.86 recurring. Correct? Similarly, children, we can perform any number of divisions. Right now on the screen, I can show you a slide where we have performed some divisions. Just for your understanding, you can see out of them a few are terminating ones. Terminating means what? Having a remainder 0. A remaining few are recurring ones. They are not going to terminate. They will not have a remainder 0, but either a particular number or a particular sequence of numbers, a series of numbers is repeating after a definite period. They are repeating form. So this is the conclusion. What we can draw in from this activity is that the rational numbers decimal expansions will either be terminating or they will be recurring. So if now I were to write about the decimal expansions of rational numbers, I have understood it that there are two ways of writing the decimal expansions. On your screen you can see right now that yes, very rightly we have found it out that rational numbers will be of two types. Either they will have terminating decimal expansions, that is remainder comes out to be 0, the division terminates, the division stops, or they will be recurring, that is a particular number in the quotient recurs, the remainder repeats itself, hence the quotient repeats itself. So this is what we can see now here on our board. The rational numbers are of two types, either terminating ones or recurring ones. So rational numbers are either terminating or recurring. Examples are 1.123, 0.004, 2.2, etc. All these are the terminating ones. For recurring ones, we can give you a few examples. Examples like, you can say just now we had seen the answer 0.86 bar dot over 6 or 0.333, which could also be written as 0.3 dot, or in some cases 1.171717, which could be written as 1.17 with a bar over 17. So that's how we have the rational numbers, either terminating or recurring. Moving on, if we look at a few examples of irrational numbers, we knew the irrational numbers were root 2, root 3, root 5 and so on, along with pi. And I had also told you the value of pi is up to 200 decimal places known, and beyond that it goes on, it goes on. Right now on your screen you can also see the long division method which we have learned in our grade 8, finding square roots. Correct? So using that long division, if we find out the value of root 2, as you can see on your screens, the value of root 2 is 1.4142135 and so on. See, the value is going on increasing, correct? So now if you look at this value very carefully, I can see that the decimal expansion is not terminating, neither something is repeating. As in this case, we had seen either it used to terminate or a particular number used to repeat. But in case of irrational numbers, the decimal expansion will neither terminate nor recur. And that is very special about irrational numbers. So now we are going to write that the decimal expansions of rational numbers, as we had said, were either terminating or recurring. Similarly, decimal expansions of irrational numbers are neither terminating nor recurring. They are not going to terminate, not going to recur. म्हणजे ते आपलं काहीच ऐकणार नाहीये. टर्मिनेट पण होणार नाही, रिपीट पण होणार नाही, काहीच करणार नाही. नको करूस, काहीच करणार नाही. तर इरॅशनल नंबर सिंपल, जो ऐकणार तो रॅशनल, जो नाही ऐकणार तो इरॅशनल. सिंपल थिंग इट इज, राइट? Either he will terminate like a good boy or he will repeat like a good girl. So it is either terminating or recurring for rational. Neither terminating nor recurring. हे पण ऐकत नाही, ते पण ऐकत नाही. It becomes a, that is why we call it as a irrational number. You can say like that, correct? So the numbers are neither terminating nor recurring. So mind well, a very important point. Whenever you will be writing an irrational number, this dot which shows that it is not terminating is very important. Very quickly what we'll do is that try to write few rational and irrational numbers. Okay, so now see what. Now if they have asked me to write say 3 rational and irrational numbers between 2 and 3, correct? Now we want the numbers between 2 and 3. You know that 2.1, 2.1, all those numbers till 2.9 will lie between 2 and 3. So I want 3 rational numbers. How are rational? Either terminating or recurring. So now what will I get? See, can I write 2.123? This is a terminating one, hence a rational number. Or 2.2222. Recurring one. See, recurring is also rational. Terminating is also rational. And it is between 2 and 3. Between 2 and 3 lies 2.222. So, or else one more number I can take. 2.56727272 and dot. This 72 is repeating. Means what happens? This number was your 2.123. This number was actually 2.2 bar. This number was 2.5672 and bar only over 72 because only 72 is repeated, but it is recurring now. It is recurring. So these were the 3 rational. Likewise, how many you can find? Yes, infinitely many. You know that. You can find any damn number. 2.123, 124, 125, 126 or 2.111112222333 11121314 in a repeating pattern. Correct? So these become the repeating ones, recurring ones or the terminating ones. Similarly, now if I want an irrational number, what is the condition? Neither terminating nor recurring. See, what do I write? 2 point, I don't want to terminate, I don't want the expansion to recur, but it must be between 2 and 3. 1, 2, 3, 4, 5, 6 and so on. Is it terminating? No. Is anything repeating? No. Neither repeating nor terminating, irrational. Or 2.10, 1100, 1100, anything like that. See, and very important, dot, because it should not terminate. Correct? Neither it is repeating. See, here it is 10, but here it is 1100. Here it is 1,11,000. So nothing is repeating. Don't worry. Or I can even write 2 point my mobile number, my father's mobile number, and dot dot dot, because nothing is repeating. Let me give an example. 97300730058 dot dot dot. Nothing is repeated a particular pattern nor the ending numbers. Or I can also write 2.987654 dot dot dot. Neither terminating nor recurring. Irrational numbers between 2 and 3. So likewise, how many irrationals now you can find? Exactly, infinitely many. So today's point was decimal expansions for rational and irrational. The rational numbers will either terminate or they will recur. Irrational numbers will neither terminate nor recur. That's all for the decimal expansions. We will be soon coming with the next part. Thank you.